In the last video, we discussed about how do we write the data in tabular form. We call grouped frequency distribution table, right? So after you write the table, after you organize the table in a nice looking form, the next thing you want to do is you want to draw the graphs of those data sets, okay? The graph is easy to see for the non-math people too, okay? For the table, only the statistician or mathematics people understand the table, but the graph anybody can understand. So the graph attracts the audience attention and easier to see main features, easier to understand for non-statistician also. Okay, so these are the examples of the of some of the pictorial representation of the graph. The first one is histogram, second one is polygon, and third one is the cumulative frequency polygon, and so on. Okay, now how do we draw the histogram, how do we draw the frequency polygon, and so on is discussed next. Okay, so histogram and its construction. The histogram is a graph that displays the data by using contiguous vertical bars, unless the frequency of a class is 0, of various heights, to represent the frequencies of the class. We write the class boundaries along x-axis. So to draw the histogram, we write the class boundary along x-axis, and then we draw a rectangle with height equal to the frequency of that. For example, look at this. This is an example of group data, right? Class boundary is given, frequency is given. Now, so to draw the histogram, what you do is you need to plot all these class boundaries, all this lower limit and the upper limit of the last class along x-axis. See, 99.5, 104.5, 109.5, and so on. You write all those. And then between 99.5 and 104.5, the height is 2. So you draw a rectangle of height 2, like that. Similarly, between 104.5 and 109.9.5, the height, the frequency is 8. So you draw a rectangle of height 8. And you continue that way. One of the main feature, very important thing about drawing a histogram is you need to have class boundary. If class limit are given, you need to first find out the class boundary, the method we used in the last video, and then write down them, mark the class boundaries along x-axis. Do not repeat. For example, don't write 99.5 through 104.5 and then again 104.5 to 1. Don't repeat the number. You just write once 99.5, 104.5, 109.5, and so on, and write down the upper limit of the upper boundary of the last class, all those here, and then write rectangle of the heights given here. Okay, now shape of the distribution. Look at this. If the histogram are bell-shaped, we call bell-shaped or symmetric or the normally distributed. If the histogram have longer tail on the right, for example this one, see, longer tail on the right, right? That is called positively skewed or right skewed or longer tail on the right. And then negatively skewed is if there is a longer tail on the left, then it is negatively skewed, left skewed, or longer tail on the left. Okay. From the frequency distribution table, you can guess the shape of the histogram. For example, if the middle frequency is big and then the frequency are decreasing on either end, then it is normal. If there is smaller frequency on the right side, that is right skewed or positively skewed. And if there are more smaller frequency on the left or on the beginning, then that is the left skewed. Okay, look at these shapes. This is the normally skewed because it is like bell shaped, right? You see that? And this is called uniform, meaning all the heights are almost the same. This is longer tail on the right, that is right skewed. This is longer tail on the left, that is the left skew. And this is J shaped, and this is reverse J shaped. This is bimodal. This has one peak and then other peak, right? And this is U shaped. You see that? That's the shape of the distribution from the histogram. All right. So for the following data with class limits, construct a histogram. That's another example. The data is the salaries in millions of the dollars of 31 national NFL teams per season. So the class limits. So 38.9 million through 43.8 million, there are 5. Okay. And 5 teams. 43.9 million through 48.8 million, 8 teams, and so on. These are these salaries, class limits, given in the limit form, because there is a gap between this. It ended at 33.8 and starting this one is starting at 43.9, so there is a gap. So this is the class limit, right? Now, so you want to draw the histogram. To draw the histogram, you need class boundary. What is the gap? Because there is 1 decimal place there, right? There is 1 decimal in the class limit. So what you need to do to find out the class boundary is subtract 0.05 from the left limit and add 0.05 on the right limit. Then you will get the class boundaries will be 38.85. If you subtract 0.05, you will get 0.85, 0.85, 0.85, and so on. And that will be 0.85 as well. So 38.85 through 43.85. 43.85 through 48.85. See, now we will plot these values in x-axis, but don't repeat, because there is 43.85, 43.85. Don't repeat. Just write the different one. See, 38.85, 43.85, 48.85, 53.85, and so on. And what are the frequencies? Frequencies are the same. 5, 8, 7, like that. So you draw the rectangle of 5, 8, 7, and so on. You continue drawing that way. Okay, this is the histogram. And what is the shape? It is the right skew, right? Because see, there is a longer tail on the right. You see that there are smaller frequencies on the right end, or the lower end, on the upper end. That's why it is the right skewed. Now, what is the frequency polygon? There are 2 ways you can draw the frequency polygon. One way is you find out the midpoint. Let's say xm is the mid value. How do I find out mid value? Add this plus that number and divide by 2. 38.9 plus 43.9 divide by 2. Similarly, this plus this divide by 2. This plus this divide by 2. So you get the mid values and plot those mid values along x-axis. Instead of plotting these, plot the mid values. This is one way. Another way is just pick the mid value here. That midpoint of the top, midpoint of the top, midpoint of the top, midpoint of the top, and then join them with a line segment. Okay, it is not a single curve, but just a line segment. That is another way. And at the end, we try to close that curve. So the idea is you can find the mid value. There are 2 ways you can do it. One way is find the mid value of each class, and then plot mid value and the frequency. The other way is just mark the mid value of each rectangle, top of each rectangle, and join them with the straight line. Okay, so look at this. On this example, to find out what is the mid value of this, you just add this plus this divided by 2. So you will get, let's see, exactly the same example on example 1b. So this is 41.45 is the mid value of the first class, 45.45, 49.45, and all these are the mid values of the classes. They all go to the x-axis. Okay, and then for y-axis, that will be the frequencies. Okay, so for 41.45, the frequency is 4. For another one, the frequency is 4. For another one, it's like that. Okay, now look at this. At 37.45, because this 30, so what is the midpoint of the first class? Is 41.45. Okay, so that's the mid value. That's the 4 is the frequency. Now what you do is usually we add that to the previous value. You just add, because see, these are the difference is 4, right? 41.45 is the mid value of the first class. 45.45 is the mid value of the second class. This is the mid value of the third class. What we usually do is we want to close this curve. We want to join this with x-axis. So you go 1 step back. That will be, this minus 4 will be 37.45, and then join that. Although it started from here, this is one point, this is another point, and you join that. But usually this is the last point from the table. But you add that. You go 1 step right and join that, and 1 step left and then join that one. Okay, that's what you do. Alright, that is the frequency polygon. What is the ogive? So ogive is similar to the frequency polygon, but what we do is we plot for the cumulative frequency. Not the frequency, we plot the cumulative frequency. Okay, on this example, first of all we need to find out the cumulative frequency table. Okay, so how do I do that? Less than 4.5 is 0, less than 8.5 is 12, less than 12.5 is 12 plus 15 is 27, and so on. You find out the cumulative frequency, And after you do that, what you do is you plot these class boundaries along x-axis and these value along the y-axis. Okay, you just plot them along y-axis and then join them. Look at this. What is less than 4.5 is 0. At 4.5 it is 0. Mark this point. What is less than 8.5 is 12. At 8.5 it is 12. Mark this, mark this, mark this, and then continue marking those values, marking these values, okay, and then join them. That is called the ogive. All right, ogive. All right, so these are the pictorial representation of the numerical data, or the data that are represented in the number. Okay, but how do I represent the categorical table into picture? That is the next thing I'm going to do. Okay guys, thank you. That will be in the next video.